June 7, 1944. H-hour plus 24. The beaches of Normandy were not yet secured. Amidst the chaos of the landing zones, the Allied momentum hinged on one thing: resupply. But as vital crates of ammunition and medical supplies were offloaded onto the damp, shell-churned sand, they were failing. The seawater and mud instantly compromised the fragile wax seals of the transport boxes. Soldiers, fighting their way off the beach, were running low because their supplies were literally disintegrating before they could reach them. The enemy here was not just the Wehrmacht, it was moisture and time. Yet, amid this massive logistical failure, a simple solution, born from an ordinary factory worker's fierce ingenuity, held fast. It was green, unassuming, and utterly waterproof. It was the duct tape, a simple strip of cotton and rubber. This wasn't a tank or a plane. It was the ultimate, unsung force multiplier that kept the Allied supply lines functioning when everything else buckled. This is the story of how a mother's letter to a president solved a critical battlefield crisis, creating a secret weapon that was more valuable than gold: the power to keep things together. By 1943, the sheer scale of American supply lines was a triumph of industrial output, yet a critical, seemingly minor flaw threatened to undermine everything: the inadequacy of packaging seals. Ammunition, crucial radio components, and life-saving plasma were typically secured using waxed cloth tapes or coarse rope. On the front lines, these failed spectacularly. We have veteran accounts describing crates where the paper seals would literally dissolve after a single rain shower or landing in shallow, salty water. This meant moisture seeped into ammunition canisters, potentially degrading propellant powder, leading to misfires or worse, rendering entire supply caches unusable. Furthermore, accessing the contents required soldiers, often with one hand occupied holding a weapon, to fumble with a knife or awkwardly rip stiff materials. The logistics problem had become a tactical liability, turning every supply run into a gamble against the element. The search was on for a material that was strong enough to resist the global climate but simple enough to be accessed in a high-stress, single-handed maneuver. The catalyst for this multi-million-dollar military innovation was a working mother named Vesta Stout. Employed at the Green River Ordnance Plant in Illinois, Vesta's job involved inspecting and packing ammunition belts. Unlike the generals in Washington, Vesta witnessed the logistical flaws every single day. She saw firsthand how easily the waxed seals tore off or how much effort was required to pry them open, leaving exposed contents vulnerable. Her motivation, however, was intensely personal. She had 2 sons serving in the U.S. Navy. Haunted by the thought of her boys, or any soldier, dying because a delay in opening a box of ammo, Vesta took decisive action. After her supervisors dismissed her concerns, Vesta's frustration culminated in a radical move. She penned a direct, passionate letter, not to a congressman, but straight to the highest office, President Franklin D. Roosevelt. She didn't offer a design. She offered a direct challenge born of necessity. Vesta Stout's letter, a handwritten plea from the factory floor, achieved the near impossible. It bypassed the military-industrial bureaucracy entirely. President Roosevelt, known for his keen appreciation of logistical detail, recognized the immediate, critical validity of her complaint. He immediately directed her letter to the War Production Board, WPB, giving the matter the urgency of a high-priority weapons project. The message was clear: find a solution and find it immediately. This unprecedented intervention streamlined the entire process. The problem, which had festered for months in the supply corps, was now catapulted to the top of the war effort's agenda, marking the moment when a simple factory worker's observation transformed into a nationwide technological imperative. The pressure was enormous, and the race to deliver this impossible tape was on. The task of developing the breakthrough material was handed to the Revellite Corporation, a small subsidiary of the colossal Johnson & Johnson Company, which specialized in medical and surgical tape. WWII's engineers were experts in adhesion and fabric backing, but they had never tackled a problem of this magnitude, a tape required to withstand saltwater, jungle humidity, freezing temperatures and ballistic shock, all while remaining tearable by hand. Their immediate challenge was identifying the correct materials. They needed a backing that was not only strong enough to resist tearing along its length, high tensile strength, but could also be cleanly ripped across its width. The adhesive needed to be aggressive enough to stick to damp, metallic ammunition canisters, yet not so aggressive that it left irreparable residue. This was a complex, multi-layered problem of applied chemistry and textile engineering, with the fate of Allied logistics hanging in the balance. WWII's technical breakthrough centered on the choice of the backing material. They selected a dense, yet flexible, cotton mesh fabric, the same type of material often referred to as duck cloth in the textile industry due to its dense, water-resistant weave. This material provided the critical structural integrity. By treating this fabric and backing it with a newly formulated, thick layer of natural rubber-based adhesive, the engineers achieved the impossible mandate. The dense cotton mesh gave the tape its longitudinal strength, preventing it from stretching or breaking unnecessarily, while the segmented nature of the weave allowed a sharp, forceful tug to cleanly tear the tape across its width. This material was then coated with a waterproof laminate. The resulting product was robust, conforming, and, most importantly, ready to withstand the rigors of the global conflict. The duck cloth had delivered the goods, and the name, duct tape, was already being whispered across the factory floor. The true secret of the tape's success on the battlefield lay deep within its chemical formulation, the aggressive, thick rubber-based adhesive. Unlike paper-based glues that disintegrate upon contact with moisture, this rubber compound was naturally hydrophobic, water-repelling. This was critical for the logistical integrity in both major theaters. In the swamps and jungles of the Pacific, the adhesive resisted the relentless humidity and salt spray, which notoriously stripped older glues from metal. In the cold, muddy winters of Europe, the adhesive maintained its tackiness and flexibility, resisting the brittleness that plagued other materials at low temperatures. The rubber provided not just an attachment, but an instant, flexible gasket, sealing the seams of metal canisters and preventing rust and moisture from destroying the contents. This resilience elevated the tape from a mere sealer to a certified environmental barrier. The initial color specification, a flat, non-reflective olive drab (OD green), was a direct military necessity. The last thing a soldier needed was for a shiny object to glint in the sun and betray his position to a German sniper or a Japanese patrol. The OD green coloring allowed the tape to blend seamlessly with the canvas, fatigues, metal equipment, and vehicles used by the U.S. Army and Marines. This camouflage was essential for maintaining the operational security of supply dumps, temporary repair sites, and field expedient shelters. Furthermore, the matte finish was designed to absorb light rather than reflect it, ensuring that even when used on larger surfaces, like repairing a Jeep hood or a tent roof, the enemy's visual reconnaissance would not pick up on the telltale sheen of a foreign material. The single-handed tear capability was the duct tape's most revolutionary tactical advantage, born directly from Vesta Stout's observation. In the chaos of a firefight, a soldier's capacity for multitasking is severely limited. Whether reloading a machine gun belt, applying a tourniquet, or reaching for a smoke grenade, the soldier needed a solution that was immediate. Because of the engineered cotton mesh, the tape could be ripped clean with a sharp, vertical tug, without the need for a knife, scissors, or a second hand to stabilize the roll. This seemingly minor detail was a game-changer in situations demanding split-second speed, from quickly securing a radio pack that had come loose, to tearing off a strip to label a captured position under duress. The simple act of the tear saved vital seconds that could, and often did, save lives. The ultimate test of duct tape's logistical role came during the preparations for Operation Overlord D-Day. prior to the invasion, hundreds of thousands of pieces of critical equipment, from the sensitive electrical circuits in the Sherman tanks modified for waiting, DD tanks, to the fuel drums and medical supplies, required absolute waterproofing. Duct tape was issued in massive quantities and became the go-to sealing solution. Engineers used it to seal every joint, port, and vulnerable seam on equipment that was expected to be submerged in salt water during the landing approach. The tape ensured that millions of rounds of ammunition remained bone-dry and functional. Its pervasive, yet unheralded, use during the crucial build-up and staging phases contributed directly to the unprecedented logistical success of the Normandy landings. Once deployed beyond its intended use for sealing, the duct tape became the infantryman's best friend for field expedient repair. Anecdotes from the European and Pacific theaters highlight its versatility. Jeep mechanics relied on it to temporarily patch cracked distributor caps, seal leaking oil lines, or secure damaged headlights after a crash. Signal Corps operators used it to insulate frayed communication wires, quickly splice broken field telephone lines, and secure fragile radio antennas to prevent wind damage. The tape's ability to adhere firmly to metal, rubber, and plastic made it an unofficial, yet indispensable, part of every toolkit, allowing damaged equipment to stay functional just long enough to maintain the push forward. While frontline combat defined the war, supporting the forces required massive, rapidly constructed infrastructure. Duct tape proved its mettle in the rear areas, particularly in the construction and maintenance of Quonset huts and large military tents. These prefabricated structures were vital for housing troops, storing sensitive equipment, and establishing field hospitals, yet their canvas and corrugated metal components were prone to leaks and wind damage. Engineers used the tape extensively to seal joints between metal sections, patch rips in heavy canvas tent roofing, and secure makeshift insulation against the chilling European winters or torrential Pacific downpours. The tape became an essential low-tech sealant that ensured these vital, temporary homes remained weatherproof and habitable, a silent contributor to troop morale and the maintenance of essential rear area operations. One of the most ethically complex yet crucial applications of duct tape occurred in the hands of field medics and Navy corpsmen. While not a sterile medical supply, its strength and moisture resistance made it invaluable for improvised life-saving procedures. The tape was frequently used to secure fractured limbs to splints, providing a far stronger and quicker immobilization than standard gauze or fabric ties. Crucially, its waterproof nature was leveraged to create a temporary contamination barrier, sealing gauze and field dressings around open wounds to keep out the pervasive mud, dirt, and water until the wounded could reach a sterile field hospital. This unauthorized use highlights the tape's reliability. Medics, facing desperate conditions, trusted it with the lives of their patients, confirming its reputation as the ultimate material of last resort. The brutal environmental conditions of the Pacific theater presented a profound challenge to adhesive. The constant, suffocating humidity and corrosive salt spray quickly degraded most conventional glues and metals. Duct tape, however, thrived. The dense weave of the cotton backing, combined with the resilient, rubber-based adhesive, allowed the tape to maintain its tackiness and structural integrity even when constantly soaked in salt water. It was deployed extensively by the U.S. Navy and Marines to seal critical gear on landing craft, patch small holes in rubber utility boats, and protect vulnerable instruments from the relentless atmosphere. Its proven resistance to corrosion and moisture made it indispensable for operations in island-hopping campaigns, distinguishing it sharply from every other adhesive material deployed in the region. In modern warfare, communication is life. The vast network of field telephone lines and radio cables laid across trenches and forests were constantly being severed by shelling, tanks, or sabotage. The rapid repair of these lifelines became a critical logistical function. Signal Corps operators relied heavily on duct tape for quick insulation and splicing. The tape's robust rubberized backing was excellent for weatherproofing exposed copper wiring, quickly restoring the connection that carried vital intelligence, fire commands, and medical evacuation requests. It secured fragile antenna connections against high winds and was often wrapped around battery packs to provide an extra layer of shock protection, ensuring that the voice of command was never silenced by a simple severed wire. The value of the green duct tape became so universally recognized among soldiers that it fostered an informal black market on the front lines. Supplies of the tape were often tightly controlled, yet the demand for a personal roll was enormous. Soldiers would frequently trade, barter, or unofficially exchange the tape for other scarce items like cigarettes, quality rations, or extra fuel. This sticky fingers phenomenon served as an undeniable, if unconventional, testament to its worth. The tape was not just equipment, it was a highly liquid form of currency, underscoring the deep trust and reliance soldiers placed in its ability to solve the thousand small, chaotic problems that plagued daily life and combat on the front. Before major amphibious landings, particularly the Sicily invasion, Operation Husky, and the monumental Normandy landings, duct tape was integrated into the critical process of waterproofing heavy armor. Tanks, trucks, and specialized engineering vehicles, like the Hobart's Funnies, were equipped with deep wading gear, but vulnerable areas remained. Engineers used massive quantities of the heavy-duty tape to seal engine vents, exhaust pipes, and gun mantlets, ensuring that salt water would not instantly short-circuit vital electrical systems or flood the engine compartment upon exiting the landing craft. This meticulous, labor-intensive application of the tape was a fundamental requirement for the survivability of the invasion vehicles, directly contributing to the percentage of armor that successfully reached the shore and could immediately enter combat. In the execution of dangerous airborne operations, such as the pre-D-Day jumps and operations in the Pacific, every piece of equipment carried by paratroopers had to be secured against extreme shock loading. When jumping from planes, equipment bundles often separated, leading to loss or damage. Duct tape became essential for tightly binding rifles, ammunition pouches, and specialized gear to the paratrooper's body or securing items to the parachute risers. Its tenacity ensured that these critical items, from radios to explosives, remained firmly attached during the violent shock of the jump and the subsequent landing, a low-tech method providing essential insurance for the war's most high-risk missions. Field artillery and mortars, which endure massive shock and vibration upon firing, constantly suffered equipment failure and component loosening. Artillery crews utilized duct tape as an essential rigging tool. It was used to secure loose fuses, keep sensitive site mechanisms protected from dust and rain, and stabilize connections on the firing systems. Moreover, when temporary artillery positions were established, the tape was often employed to reinforce sandbags or secure temporary aiming stakes, ensuring that the precision of the indirect fire, a backbone of battlefield support, was not compromised by the constant stress of heavy bombardment. The U.S. Navy and Marines relied heavily on inflatable rubber boats, dinghies, and specialized rubber pontoons for reconnaissance, infiltration, and coastal operations. These craft were highly vulnerable to shrapnel and sharp coral. The unique composition of the duct tape, rubber adhesive paired with a flexible fabric, made it highly effective for performing emergency, temporary patches on these rubberized surfaces. A quick application could seal a small puncture, preventing air loss and saving the crew, proving its worth not only on land but also as a vital emergency repair solution in high-risk marine environments. The astronomical demand for duct tape required continuous, prioritized manufacturing throughout 1944 and 1945. This put significant pressure on the allocation of strategic raw materials, particularly the natural rubber used in its adhesive, which was heavily restricted during the war due to the loss of Asian supply routes. The continuous government allocation of synthetic rubber and high-grade cotton to the tape's production underscores its extreme importance. The military viewed the output of the duct tape factories as a priority comparable to other essential equipment, demonstrating that its logistical utility justified the immense consumption of vital, scarce wartime materials. The unique chemical composition of duct tape's rubber adhesive and its specialized curing process were not made public. The War Department and the manufacturers understood that the tape represented a significant logistical advantage, a form of silent technological superiority. The precise formula was treated with a high degree of military secrecy, carefully guarded to prevent Axis intelligence from acquiring samples, reverse engineering the material, and replicating the tape. Protecting the formula was paramount. If the Germans or Japanese could solve the problem of quick, waterproof sealing, the Allied logistical edge would be compromised. Beyond the battlefield, duct tape found a critical, temporary role on the home front in relation to civilian defense protocols. During air raid drills and actual alerts, cities in Britain and the United States required strict blackouts. The tape was used by civilians and local defense groups to quickly and effectively seal light leaks around windows and door frames, securing heavy blackout fabric in place. This home front utility further demonstrated the tape's versatility and its ability to adhere to materials far beyond military specification, making it a double-duty wartime essential. Crucial to the Allied success was the material deficit faced by the Axis powers. While German and Japanese forces utilized various specialized adhesives, they never mass-produced a field tape that matched the comprehensive performance of duct tape. German materials often relied on less durable paper or synthetic glues that failed quickly in high moisture. Japan's reliance on often inferior rubber compounds and lack of heavy cotton fabric production meant their field tapes were easily degraded by the extreme heat and humidity of the Pacific. This deficiency forced Axis logisticians and field mechanics to rely on slower, less reliable sealing methods, contributing to their overall lower operational readiness. For the engineers of the Army Corps of Engineers and the Seabees, Naval Construction Battalions, the tape achieved almost mythic status. Engineers were known to use it to perform repairs that conventional wisdom deemed impossible, temporarily sealing fractured fuel drums, fixing large leaks in jerrycans, reinforcing damaged water purification equipment, and even creating rudimentary tools by binding objects together. The joke, often repeated, was that if a problem couldn't be solved by a hammer and a roll of duct tape, it couldn't be solved at all, a testament to the profound reliance the technical professionals placed in its brute force capability. In the final, critical campaigns of 1945, particularly the crossing of the Rhine River, duct tape played a final, vital role. As Allied forces utilized massive pontoon bridges and temporary ferries, all equipment needed to withstand the cold, fast-flowing river water. The tape was essential for sealing equipment loaded onto the pontoon sections, securing lines, and quickly repairing minor damage to the bridging materials themselves. It provided a final layer of logistical assurance, ensuring the rapid and successful projection of Allied power deep into the German heartland. By the end of the war, the volume of duct tape produced for the military was staggering. While precise totals are hard to determine due to wartime record-keeping, manufacturers shipped millions of rolls to every single theater of operations. This sheer quantity underscores its shift from a simple solution to a fundamental, high-volume supply item. The production rate validated Vesta Stout's initial insight. The need was universal, and the solution had to be produced on a scale commensurate with global conflict. With the cessation of hostilities in 1945, military contracts for the olive-drab duct tape ceased immediately. The War Department was left with massive quantities of surplus material. These rolls were sold off to civilian contractors and industrial liquidators as part of the post-war industrial surplus. This massive influx of the durable, waterproof tape into the civilian market provided the initial bridge for its subsequent transformation, making its qualities known to builders, farmers, and factory owners. Civilian mechanics and builders who acquired the military surplus quickly discovered the tape's extraordinary properties. They found it was perfect for tasks the military hadn't even conceived of, particularly the rough sealing of joints and minor repairs on new heating and ventilation (HVAC) ductwork. Its ability to stick to galvanized metal and withstand mild temperature fluctuations made it an instant favorite in the construction trades, a new market that would eventually lead to the tape's famous color change and its universally recognized name, duct tape. Vesta Stout's incredible contribution was formally recognized after the war. Though she never sought fortune, the military brass acknowledged that her personal courage and ingenuity had saved countless hours of logistical delay and protected untold quantities of supplies. Her legacy remains a powerful narrative testament to the idea that the most profound and essential innovations often stem from the practical, on-the-ground observations of ordinary workers rather than specialized research labs. The final conclusion of its wartime history is clear. The green duct tape became the ultimate, low-tech symbol of American wartime ingenuity and improvisation. It proved that the most sophisticated problems could sometimes be solved by the simplest, most robust material. From the muddy beaches of Normandy to the humid jungles of Guadalcanal, this small roll of cotton and rubber became an essential part of the Allied success. A humble, flexible weapon that taught the world the universal power of keeping things together when the world was otherwise falling apart.